Hello guys, in this video we will talk about basic components of system design, how these components interact with each other and accomplish a task that is required from the system. Okay, so the first component is domain name server. So when you type a website name in the browser address, that website name is converted to an IP address. Okay, and that is with the help of domain name server lookup. Domain name server will convert the website names to a IP address. So most of the domain name server websites are cached in your PC, but if the website that you are trying to access is not part of your local PC cache, then internet provider will help you get the IP address, because internet provider itself has its own DNS lookup, and that DNS lookup is cached through the internet provider. Now we'll move on to the next component of system design, which is CDN, guys. CDN is content delivery network. So CDN significantly reduces the fetch time of your websites. So why? So CDN consists of origin servers and edge servers, which helps in faster loading of the website. So suppose I have my website. My website is hosted on a server which is located in Mumbai. Now there is a user who is trying to access my website from New York. Because of the huge distance between US and India, it will take him more time to load the website, and the performance of the website is reduced basically. So for me to have a good load times or fetch time of a website, I will use CDN. I'll go to Akamalai or I'll use Cloudflare. I'll say them, see, I want to put my contents of the website on your network, which is content delivery network, so that my fetch time of the website is faster for the people across the globe. CDN itself is a big system. Companies like Cloudflare, they own their own data centers across the globe, but it is very important part of system design because it significantly improves the performance of the system. Even our YouTube videos and some of our Instagram trending reels are on the CDN, so that the load times are really faster. Now we'll move on to our next component, which is load balancer. Load balancer is used to balance the load. What does that mean? That in the application server, if there are 10 pods running and there are 100 requests coming, how do we want to load balance the request? We can use round robin. We can use other algorithms also for the load balancing, like least CPU used or idle. There are many algorithms that can be used with the load balancing to serve the request. Now the next component of the system design that we'll use is our application servers. What are application servers? So all the business logic that we want to do for the request is on the application server. So these servers are basically, nowadays when we have almost moved away from the monolithic design, from monolithic to VM, and from VM to containerization. So mostly software developers and people, they are creating Docker images of their package, of their whole application, and those Docker images are run using container orchestration, which is Kubernetes. Okay, so this itself is a system which we'll explain in the upcoming videos. There are communication protocols, there are security involved in it, there's a persistent volume, how the application servers are using CPU and how the application servers are using RAM. This is all basically used in our application servers. Then we'll move on to cache. The cache, as the name suggests, it will cache all the data on the memory. So cache will put data on the memory and DB puts data on the disk. So reading data from the disk for CPU will take more time and reading data from the memory will take less time. So we want to cache all the frequently used data by the users so that again the performance of an application is improved. We get the response time is less. If the response time is less, the users he can be able to keep on doing the activity on the website. There are cache available in the market like Redis cache, which is very popular. There's mem cache, and then there is an application cache that I sometimes use because there is some data for the system where there is no change. Suppose there's a data which is the country data or region data. It is unlikely to change, and this data which is unlikely to change, we can use application cache for that as well. Like Google Guava is most commonly used. Now we'll move on to the next system design component, which is database. See, honestly, database is the core component where all the data of your system is stored. So data is the new oil. So we have to use a database which is configurable, a database which aligns with the requirement of the system. There are many databases available in the market. SQL versus no SQL. SQL is a relational database. It follows asset properties like atomicity, consistency, isolation, and durability. And at the same time, NoSQL databases, which are very easy to scale. There are no relationships, and there are many kind of NoSQL databases like document, column, then graph database, then blob storage. So based on the system requirement, we select the database and we configure the database. Selection is the first part, configuration is the another part, like how much disk database wants to use. Now the next part of the system that is shown in this whole diagram is logging. So what is logging? Logging is basically to monitor the system. Is system using more memory? When is the time the CPU was used 100%? Anything crashed in the system? If pod is crashed, was self-healing of pod happened in time? How much time did it take pod to restart? This is all logging and monitoring. We call it observability, and Prometheus and Grafana are used out of the box if we are using Kubernetes, but there are other logging and monitoring tools also like Dynatrace. Okay, then we'll move on to our next part, which is logging of the data that is coming. So suppose we want to log every request that comes to a system, right? Supposedly if there's any problem, we want to see the logs, why the problem happened, and we want to push it to E3. So we are using Splunk and Elasticsearch for that. So for application logs, which is the business logs, we use Splunk and Elasticsearch, but for logging and monitoring we use Prometheus, Grafana, or maybe Dynatrace. Dynatrace will help us know exactly what is happening to the application, what we call observability. Thank you guys. I'll cover most of these components with a deep understanding in my next upcoming videos. Thank you.